Bismillahirrahmanirrahim. Assalamualaikum. I am Muhammad Syamel bin Sahidin from Group 3. I am with two of my friends, which is Muhammad Zahin Hafizi bin Sahnizam and Muhammad Arif Aiman bin Muhammad Fauzi. So we will be presenting on SPSS about frequency analysis and reliability tests, which will be covered by Zahin, and T-test and ANOVA will be presented by me, and correlation and regression, which will be presented by Muhammad Arif Aiman. We are equipped with three items, which is this data set and a set of questionnaire, also conceptual model framework. So without further ado, I will pass this to Zahin for him to present about frequency analysis and reliability tests. So let's go.
Alright. Firstly, we will doing the frequency analysis. Usually, frequency analysis using for statistical procedure that used to summarize categorical and sometimes numeric value or data variables. So to prove that the information and how often each value of variable occurs and help identify the pattern, outliners or any error. So this is for to count or display how many times each value of the variable appears in the data set, and also to survey the data demographic or categorical. Okay, firstly we will start the analysis of frequency analysis. First, we're going for the analyze, and then go for descriptive statistic and going for frequency. So at here, able to see there are two box, the variable and also the each point. So we will choose the traveling partner. We click here and going for the variable, and so we will choose the statistic. We choose for central tendency, mean, median, mode, and so sum. And also don't forget the standard deviation and click continue. So for the chart, it's okay not to chart. And okay, just click OK. Alright, here, able to see, have two box for statistic and also traveling partner that we choose before. These variables about the traveling partner. So, for the first one, and show all 267 respondent as proof to answer this question and no missing data. And by the mean was 3.08. On average, respondent that selected type coded near 3, which family and relative, more to going to Melaka. And also, the median 3.00, mean median respondent also on 3 group, pointing to the family and or relative. For the mode 3, most frequent respond also 3, at the same group. And also the standard deviation 0.861, around average also. And lastly, the sum was 822, numeric number code used for the travel partner response. So for the traveler partner, can be tell the majority are family and relative, showing the percent 68.5%. That indicate a strong preference for family as a best tourism. And able to see spouse are the lowest percent of this traveling partner. And also the variable label mean is clean data because no missing value, because the last analysis still 267 respondent with 100% respondent. Alright, after finish doing the frequency analysis, we will going for reliability test. In this SPS, reliability are used to measure the internal consistency of the scale of the item and tell how well the item in the question test measure with the same concept. As example, we going for the framework. We will choose the destination attractiveness for the from the framework, and then this the example of the question we will look alike. So in the SPSS analysis, we will start doing the data set. First, we will going to choose analyze as before, and then we going for scale and click on reliability analysis. Okay, here able to see there are three items that have choose from the framework as the example, and then going for the statistic, and here click for item scale and also scale and deleted, and also for the correlation. So we will continue, and for the scalable type attraction as the label, and just click OK. Okay, here look alike after the analysis done. This SPSS output show the result of the reliability analysis by using cross-batch alpha that we choose before, and for the name scale attraction as we typed before. So firstly, we will going define that in this thesis process summary, case valid 267 and 100%. So it means all the 267 respondent data used fully without any missing or removed data. It show a complete and clean data set. And here, reliability statistic, the crunch alpha that we use, and it show 0.835, and same goes for the standardized item 0.835, and number for item are 3. The values show that high internal consistency. In social science, a value above 0.7 are considered acceptable, and also above 0.8 is good. So the three item in the attraction that scale are reliably to measure the same underlying construct. For the standard item, meaning this item are consistent even when standardized. In simple word, can be said for the attraction scale, the reliability analysis using a crossback alpha produce a value of 0.835 on the three item, which show a good internal consistency, and using all the 267 respondent are valid with no missing data. This means the item used in the scale are reliable and measure in the same construct or same group at the show 0.601 moderate and would imply the redundancy. And next for the summary, it show the mean 0.28 range of a good consider for the construct like participant or any attitudes. And then for the term statistic, able to say an easy word, if any deleted are lower than the overall alpha, meaning it will redundancy reliability. All items are valuable and contribute a positive to the scale. Okay, so here able to say that each item contribute positively to the scale and show at a corrected item total correlation. So, reliability testing ensure the quality and consistency of the data.
Okay, Bismillahirrahmanirrahim. So now we want to do t-test and ANOVA. So t-test is used in SPS to compare the means of two groups and see if they are significantly different from each other. So the steps are: we click analyze, compare means and proportion, and then we select independent samples t-test. And then select one variable, for example this, and then grouping variable. We select gender because t-test to compare the mean between two groups, gender, male and female. So define group, continue, and click OK. Here we can see the statistic: male 67 respondents and female 200 respondents. For the significant, we can see it is more than 0.05. So when more, it is equal variance assumed. And then we take a look at the two-sided P, which is more than 0.05, which means that there is no significant difference between the two groups, which is male and female, upon the items. Okay, next we want to do ANOVA. Close this tab. First, I want to compute the variable. So I click transform, compute variable, and then type the name of variable. For example, okay, and then choose all the variables. Bracket first, then plus, oh no, and then we divide. If we have like this, we have 4 items, we divide it by 4. So click OK. After you click OK, you can see the compute variables here at the end of the all the items here. And then we want to do ANOVA. ANOVA is analysis of variance, which used to test whether 3 or more groups. So if t-test is for 2 groups, ANOVA is for 3 or more. So what we're gonna do, we click analyze, same, compare means and proportion, and we select one way ANOVA. And then on the dependent list, we include the one that we have compute. And then for factors, I want to choose number of visit. So resetting a bit. Post hop, we choose Turkey. Continue. Option. We click the box 3 below. and means plot. Select continue, and then we press OK. So here are the results. As we can see, we just focus on this. So the significant value is 0.954, which is greater than 0.05. So this means there is no significant difference between all the groups above. Here, first time visit, second time visit, third time visit, fourth time visit, and fifth time visit and above. So they all are likely similar. They all have likely similar answer between them. So there is no significant difference. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Aiman bin Muhammad Fauzi. For today, I will explain about correlation in SPSS for hypothesis testing. So, before we start, the purpose of correlation is to test whether there is a linear relationship between two continuous variables. So, after you open the SPSS, you go to at the top of the at the top, and you found analyze and go to correlate and click bivariate. So for the variables, I chose two, which is total intent and total attract. This is DV and this IV. And then after that, you go to this column, you tick for Pearson, and then for the test of significance, tick to tail, and the last one is flag significant and significant correlations. After that, click OK, and you will see the result here. First, after the result appears, you look at the n, which indicate as number of cases, which is as you can see here 267, and then we determine the direction of the relationship. So the direction which is here, as you can see, 0.459 means it's very positive, and we can conclude here is the attractive, the destination, the high people intention to travel. So after that, we need to determine the strength of the relationship, which based on Cohen guideline, which is the value here is 0.459, indicate a medium to large correlation between the two variables, suggesting quite a solid relationship between total attract and total intent. Okay, how to calculate coefficient of determination? So you need to multiply our value like this. You can see here 0.495 multiply with 0.495 equal to 0.42450. So after that, after you get the answer, you multiply again with 100, so you can get the percentage, which is the 24.5%. And then we back here. For the last is the significant level. The value of significant is as you can see here 0.000, which mean correlation 0.495 is significant statistically. So this is not coincidence in sample, but probably exists in the larger population. Okay, next we talk about regressions, which the purpose is to test whether one or more independent variables significantly predict a dependent variable. It also identify effect of the IV to DV. So the first one is you open the SPSS and click analyze and go for regression here and click linear. And then, so for dependent variable I choose total intent, and for the independence I choose 2, which is total aesthetic and total attract. After that, make sure the method is enter is selected and click the statistic button and make sure you take estimates confidence interval with 95% level. Then model fit, tick descriptives, path and partial correlations, and collinearity diagnostics. And for these residuals, you tick this one, case-wise diagnostic. Outliers outside, you input is 3 standard deviations, and after that you click continue. Okay, and then go to options and you tick this one, use probability of f, and then include constant in equation, missing values, you click this one, exclude cases pairwise, and then click continue. Now you go to plots button right here, and then use zpred for y box and z reset, I mean my bad, y z reset for y box and x zpred for x box. So after that, click on this, tick normal probability plot for standardized residual plots. After that, click continue, and then save. After that, this pop up, you click you choose the distance Mahalanobis and Cooks, and then voila, you click the continue and click OK. Alright, after this result appears, now let's check the assumption for assumption multicollinearity. In the table, as you can see here, coefficient. Alright, here the IV must be less than 0.7, as you can see here, 6.643 and 0.643 at the Pearson correlation here, and it means it passed. Now we go to coefficient tables. As you can see here, so this is where we examine multicollinearity existence. We're looking at tolerance and VIF here at the right side, at the collinearity statistic. So these two, which is tolerance and VIF, has inverse relation. Okay, at tolerance shows 0.586, which not less than 0.1. It indicates no multicollinearity. Okay, after that, on VIF, at VIF it should not exceed 10.0, as the table show here. As you can see here, 1.705 is a good result. So then it's also no multicollinearity at all. Okay, next we move to a table at, okay, here's scatter plot. Okay, the benchmark here show that we cannot exceed 3.3, positive here 3.3, maybe here around here, and negative 3.3 around here. So based on this scatter plot, we identify about 3 outliers. Okay, at the bottom here, about 1, 2, and 3 here, maybe here, this one 1. So 2 and 1 is gonna about 3 outliers. So the residual must roughly looks like a rectangle shape. As you can see here, the plot like gather here, so many here, and must be like, seems like rectangle shape. And if there are more dots, as you can see here, the more dot is like gather at the zero value here, it's mean it's a very good. So as we just find a few outliers, so we are not gonna take any action because it's only 3. So now after that we go to want to see how far the IV influenced the DV. Okay, let's go to the model summary table. Right. Okay, here. Okay. Now let's look for R square. As you can see here, 0.289 to 0.289. Now we need to convert in percentage, which is 0.289 multiply with 100 to get the percentage, which is where we're gonna get a total of 28.9%. So it explains 28.9% of the variance in travel intention. So we don't use adjusted R square like Dr. mentioned, because our respondent is about 267, which means more than 100 people, 100 respondent. So we don't need use adjusted R square. So next we move to below of the model summary table, which is ANOVA. Okay, here we need to access the statistical of the result. So on this table, the significance shows 0.0000, means we need to have a below 0.05, so it's considered significant because our significance value here right here is 0.000, so it's considered as significant. And now for evaluating the IV, we look at a coefficient table. All right, here. Okay, we move to the here. Let's check, focus on this column, standardized coefficients, which is we need to analyze which one have more impact to DV. So as a result, total attract makes the strongest unique contribution to the travel intention. The beta of total aesthetic is slightly lower. As you can see here, if compare total aesthetic beta and with to total attract 0.275 and 0.318, so this one is lower than this total attract, means here standardized coefficient of total attract is more strong. So that's all from me. Thank you for listening our tutorial. Thank you. Assalamualaikum.